Okay, hello everyone. First of all, welcome to the Biologics Educational Webinar Series. And today is the second webinar. Again, my name is Zheng Wang, today's host. I am the Vegetable Crops Farm Advisor for University of California Cooperative Extension in Stanislaus County. The credit is given to my colleague Rachel Long from Yolo County, as well as Dr. Peter Kosina from UC IPM, who's here today for technical help. All your inputs make the event happen. Okay, our today's speaker is Michael Rethwisch. He is a crop production and entomology farm advisor at the University of California Cooperative Extension in Riverside County. The topic today is about plant growth regulators. All right, Michael, I think you're ready. Thank you for coming. And now I'll let you take over.
Good afternoon, everyone. As Dr. Wang said, I'm the speaker for this afternoon, and we'll get right into this. Our topic for today, which is the biological plant growth regulators. We'll be talking about some experiences, some facts, and where we're heading for the future. All right, very good. Okay. Well, I think you probably have all seen this kind of advertisement and testimonials saying, I didn't do anything different to my grapes or whatever crop you have than I did in the past few years, except for applying product X. I don't know what it does, but it saved our grape crop, and I'm a believer. I'll definitely use it this year. Well, that's one side to the story. But let's take a look at some other comments I've heard from some of my colleagues over the years. These products don't result in statistical increases in yield. Therefore, statistically, it's the same as doing nothing. So it works, but it doesn't work. Kind of an interesting paradigm. So, and some of the things we've heard, biostimulants and plant growth regulator products, they're just another way to separate dollars from the producer's wallets. A modern day snake oil. So, kind of interesting. We have all kinds of extremes here. The question is, what is the truth? And where do we really stand? Is someone right and someone wrong? Or is everyone right? And it probably, one thing we've learned in agriculture, we know that one size does not fit all. So we'll just see what we have here. These could be great things, or these could be things that are not going to be too great. So today we're going to talk about some experiences we've had with these types of products, talk about the facts, and then we'll take a little bit of glimpse into the future. It's always good if we can all agree on what exactly is a biostimulant. And probably if there's 10 of us out there, we might all have 10 slightly different definitions of a biostimulant. So the one I'm using is a biostimulant is a molecule or a substance derived from a biological system or source that elicits a positive growth response in a different organism. And this could be a hormone, an extract, or even just a single molecule. Lots of different things out there. And so if we're looking at what they're stimulating in plants, we could be seeing faster growth, an increased systemic activated response, increased flowering, induced responses for fighting disease and stress, and a few other things. So if you really look at it, there's probably three main areas where we're seeing these biostimulant effects. One is for stress mitigation. The other one is for initiating the defense systems, like the systemic activated response. And the one I'm probably most interested in is increasing plant growth. The bottom line here for everyone is, can we economically increase yield? Because that's the bottom line. We're not doing this just for the sake of doing it. We want to have some positives for our efforts. So if we look at where the U.S. is in terms of crops, basically 97% of all the crops in the United States, as far as acres go, are agronomic crops. We've got about equal amounts of fruits and vegetables, and nuts are in there with the fruits as well. But you can see about 3% for those two areas and 97% for all the others. And if we break this down a little bit more by agronomic crops, corn and soybeans take 60% of that entire, the rest of it there, followed by wheat. And we've got forages, which is grasses and alfalfa, taking up about another 30%. So between those four areas, that's 90% of most of our crops. If we look at our fruits, nuts, and acres that way, grapes are over 1 million, almonds are up there past 1 million now, oranges, English walnuts, and we can see a lot of these things have less than 100,000 acres in the United States. So that kind of brings us to the question, with so many crop acres, why aren't biostimulants more widely used? Well, there's lots and lots of products out there that claim to increase plant growth. You know, do they provide consistent and economic production returns is another question. And if they are inconsistencies, why are there inconsistencies with these results? So we're going to take a look at some things and see what we've learned over the years. But I think it's really good to understand where we are on this. And I'm going to pose some questions for you, and I think you probably all know the answers. So what is easier to do? Is it easier to build something? Or is it easier to destroy something? And I think we would probably all agree it's much easier to destroy something than to build something. If we think about that in an agricultural situation, we probably can think about pesticides in agriculture, because with pesticides, it's easy to kill or prevent or reduce growth or some other aspect of an organism, because all you have to do is disrupt one metabolic step. But to increase growth, especially of plants, it's much more challenging, probably a factor of 10 or 20 sometimes, possibly, and it's because it's due to the multiplicity of systems involved. Genetic feedback, holding things in place, and there's lots of things going on in a plant. So in my opinion, it's much easier to kill something than to make something grow and yield better and give us an economic return. Much more challenging. So if we're going to be realizing success with biostimulants, you know, if we're going to build something the most efficiently, we have to have the right product at the right time, at the right amount to realize success. And if we think about the building blocks of plants, it comes down to basically about 5 main classes of hormones. You've got the cytokinins and gibberellic acids, you've got the auxins, you've got the abscisic acids, and you have the ethylenes. And those are really about the 5 main classes, and they do basically all the work, or a great majority of the work, for making plants grow. So they're the builders. And so we're all, with biostimulants, we're affecting one or more of these hormone levels. And as we said, we got basically 5 major classes. They're very, very powerful. A lot of these things have EPA registrations because they are so powerful, and they can be isolated by themselves. But if we think about beyond the majors, we have about a whole bunch of different minor league classes, shall we say, or minor that aren't as powerful. We have the brassinosteroids, the oligosaccharides, the polyamines, the complex polymeric polyhydroxyic acids, the GABAs, which are the GABA aminobutyric acids, We've got some osmotic acids, and there's probably a few others out there that I don't have listed. These are all out there in some of these plants as well. They interact with all these majors, and a lot of times what we're seeing with the minors, what I call the minor league ones, is that they're signaling for activity from the majors. And let's take a look at one I think we all have looked at and seen, and we're all familiar with it, is the gibberellins. It's a plant hormone. It causes plants to elongate. And last count I knew of, there's at least 126 different gibberellins. Some products out there have combinations like gibberellin 4 plus gibberellin 7 or gibberellin 4 plus 10. On the marketplace, we only really see about 5 gibberellic acid or gibberellins out there that are in the products. But they can differ widely in their efficacy. Just because of the gibberellin doesn't mean that all gibberellins or gibberellic acids are the same. I think we've all seen this or benefited from gibberellic acid. It's used widely on grapes to increase the size of the grapes. And I think every one of us, at least that I know of, has probably benefited from having a large grape to eat. It's good. It's very powerful. And we can see the size of these individual grapes in this particular picture. So we know some of these things work, but the question is, they don't always seem to work all the time, or there's inconsistencies. So what have we seen from our experiences that are barriers to the biostimulant success? And some of the things we've seen, we're not getting the correct amount of product into the plant. Sometimes it's too little, sometimes it's too much. Sometimes we're not seeing the correct surfactant being used to assist that biostimulant to get into the plant. Sometimes the nutrition doesn't allow the plant to respond. Sometimes these products are not applied at the proper growth stage. And sometimes the wrong biostimulant is being used for the situation at hand. For products that rely on fighting off stress or disease, they're kind of useless, or they don't have anything, they don't accomplish much if there is no stressor for disease for the plants to fight. And one thing we will see sometimes is often there's a combination of one or more of these above noted barriers to success. We're going to look at now some things that we've actually seen and are going to show you some examples of these. Now the picture you should have in front of you is showing a smooth brome growth response. This is a trial done a number of years ago, earlier, and it's looking at various biostimulant products and chemistries, and we're seeing how did the grass respond at this picture is at 17 days post-treatment. And you can see certain strips across here where we have really nice grass growth. And it's kind of interesting, we go back and look at all those ones that we had the really nice growth, and they all happen to have a product applied to them called Rise Up Smart Grass. And Rise Up Smart Grass, again, is gibberellin A3. We talked about it earlier on the grapes. And it's used quite a bit for grass production in New Zealand. It's been in the United States now for a number of years, and it's now being used across much of the United States to increase cool season grass production. It looks like it's a great product. We can see some really nice growth real quickly from it. On the left is the untreated, and on the right is treated, and you can see the numbers of leaves are about the same, but the leaves are bigger, they're longer, the stems are longer, and there's definitely more yield there when we go to take it for grazing or for hay. However, even with a product that is this powerful, we still can have some very inconsistent results with the product. This happened to be the same field as our earlier slide, which showed the nice growth strips. And in this particular situation, it's kind of interesting that with this application, the best growth was in the wheel tracks, which would be the opposite of what we would expect. So the question is, why are we getting the best growth in the wheel tracks and not really much growth anywhere else? It seems very, very illogical to us at the time, but it was one of our first clues in how to make these products work and work consistently and effectively every time out. So what happened in this particular situation with the tractor that had driven over the grass, it had bent the grass and probably cracked the outside waxy cuticle a little bit and allowed some of the product to get in. And this kind of told us that the surfactant that we were using, or lack of surfactant, was extremely important to making these things work. This particular slide right here is a surfactant study, all with Rise Up Smart Grass, and you can see the differences in the grass growth due to the surfactant. Some of these products didn't work at all as being an effective surfactant for getting the product into the plant. Others were very effective. So we had a good response that way. When we got done with this whole thing and looked at it, the key to using the Rise Up Smart Grass on grasses seems to be the use of a non-ionic surfactant that also contains ammonium sulfate. That seems to be the key. The NIS by themselves didn't do much. And if we think about ammonium sulfate, a lot of times it's used with glyphosate to help get into plants as well. So this is not an uncommon phenomena that's unique to plant growth regulators. It's well known with certain herbicides as well. We have to get the product into the plant. But there's other factors involved as well. This is under another situation where we're not only looking at different surfactants, but also looking at them in different areas of fertility. So we have low fertility being the blue bars. In the middle, we have the medium fertility, and the greens are the good fertility. And for the most part, you can see, with just a couple exceptions, that where we had better fertility, we had the best responses. And then, of course, some of that was also affected by the amount of product that got into the plant based on the different surfactants. Those that had the good amounts of ammonium sulfate were the ones that we were seeing really good responses. It's not true. It's not only true on smooth brome. We're also seeing it on other grasses, such as crested wheatgrass. Same sort of thing here, where as we can put the fertility on there and add some fertility, which would be the green and purple bars, we're seeing increases. But if you look at site 2, which is in the middle, the Rise Up by itself really doesn't do anything. It can signal for growth, but it doesn't happen unless you have the fertility there. One thing to remember is that biostimulants do not replace fertility. Sometimes they'll actually require more to meet the growth demands. So we've talked about a few other crops. Let's talk about some things that are more specific now to California. We're going to focus a little bit here on some of our black-eyed peas, a little bit on some onions, just to see where we are with this entire situation. So let's take a look at what we've seen here from our UCCE trials. This is a trial that was done here in Central California. This is one by Rachel. This is on black-eyed peas. And you can see very early in the growth stage, she's out there spraying the product. And as we look at it over here on the picture on the right, we can see a substantial difference in growth at 21 days between the treated and untreated black-eyed peas. Very impressive. The question is, what do we see in terms of yield? If we look at on the far left, we're seeing about a little bit about between 10 and a 15% increase in yields as far as what we saw here from the use of the Rise, in this case a ProGib 40, which is gibberellic acid. But we look at the seed weights. Seed weights are pretty much identical. So we increased the yields but we didn't really reduce these seed weights very much. So that was a good thing to see. And she's also looked at something else, a product called Excite. This was done in 2012, and this is on baby lima beans. And in this case, she put out a pint of Excite at 5% bloom, and she came back at 10 days later. And we can see what these plants looked like, and you can see the yields here. Again, where we put out that Excite at the 1 pint plus the 1 pint, we're seeing about a 17% yield gain versus the untreated. Again, seed size, pretty much exactly the same. So we're seeing some interesting things that are working, and we're going to look at these as well, because I think there's lots of promise here. But what about results from other biostimulants? We've talked about the gibberellic acids, which are very powerful, but what about the basosteroids or the oligosaccharides or the polyamines? We have other classes out there as well. Just how do they work or do they not work, and what have we seen? One of the classes I've investigated quite a bit have been the oligosaccharides. These are signaling molecules, and if we look at, a lot of times they are put out in the furrow or as a seed treatment, and on soybeans you can see what the product can do over there on the right hand. Longer root, more roots, feeder roots coming off the taproot there, and so we're seeing a larger root mass to begin with, just from the application of this product compared to the untreated. So what does this mean? Well, the first year we did this, we were very excited. Several months after planting, we were seeing some large increases in numbers of pods on the plants. And we thought, wow, we're going to have a fantastic increase from yield. But when we got down to the time of harvest, it was almost all the same. Basically, no difference. Maybe a bushel here, a bushel there. It did not meet what we thought we were going to see. In 2013, we're seeing some soil interactions here with this particular product. The yellow areas of the soybeans are where they were treated with Optimize. And the question is, why are they yellow? It's getting close to harvest here. At this point in time, they're using all the nitrogen they can. They had more pods out there. They're pulling in more nitrogen. But you can see our nitrogen levels in this low area of the field, which tend to be a bit wet, was not able to produce what it was. And we're seeing a premature yellowing of the plants because of this treatment. Wasn't everywhere, but just in this kind of low spot across the field where we had the wet spots. Now earlier, one of the comments we'd received from colleagues was, there's no statistical difference. Well, maybe yes and maybe no. We've looked at some of these products for a number of field situations, and we're looking here in the Midwest at rain-fed versus irrigated. And you can see on the far right there, as we look at the statistics, we have a very, very strong statistical difference from using these kind of products on rain-fed soybeans. But on irrigated, the statistical differences are not there. So why is there a difference? I think we have a pretty good answer on that. Even though we have a larger root system on these plants, and which is very valuable for acquiring water, and this is especially so during periods of water stress. But we know that water stress is nullified by irrigation, and that's why we're suspecting that we're seeing the differences mainly in rain-fed fields that are more stressed, in this case water stressed, than in irrigated fields. Another oligosaccharide we looked at is a product called Torque. We've used this on corn and a few other things. We did this at 4 different sites. And what did we see? Well, we can see here where we used the Torque. We're getting a significant increase in height, increase in level of chlorophyll, not quite an increase as far as a trend for colored leaves. So the plants are bigger, they got to a greater start, and we're expecting great things. And it's kind of interesting when we had a big windstorm come through and we had these stronger plants, the bigger plants, we thought we'd have more damage, and in reality we had less. It's kind of interesting, it wasn't statistical, but about 10% less plants that were wind damaged, even though they had more growth. It was stronger plants, stronger leaves, and that was how the trend was. But the growers aren't necessarily interested in the trends for damage. They want to see other aspects. So when we looked at the root zones and the roots of these things during the summer, we can see the control over there on the left, the torque in the middle, and the VITAZYME, which is on the right. We can see we had much bigger root systems from the two biostimulants, and especially when you put them up on the ends here, we could just see some big differences in how these roots were forming. And we could see it not only on the feeder roots, but we could see it also in brace roots. We also saw it with the size of the diameter of the stalks. So this would be great. You know, we got the big increase. We're expecting yield increases, and we got down to yields, and almost invariably, we had a slight yield reduction in this situation compared to the untreated check. What we suspect probably happened here is that we had bigger stalks, more nutrients are tied up in the stalks and the leaves so that were not necessarily available for finishing out the corn crop. This is one of those things where we set the plants up for success, but we suspect the yields were not quite there to bring home the potential of what had been created. So here we are. Do these things work? Are they the greatest things we've ever seen? Are they going to, be something we should shout about, or are these things just a waste of money? Well, let's dig a little deeper because, like we said, in California, we have lots of different crops, and one size does not fit all. So let's take a look at some things that we've seen. Okay, we'll look at the jasmanic pathways or the SARs, and this is a pathway that plants use to help fight diseases. Also, it's often valuable in other aspects of plant growth as well. A number of years ago, we were able to do a trial looking at 5 different melon varieties in the same field. In this case, our plots are 3 rows wide, or 3 beds wide, and we have a SAR treatment here on the right, and the entry is on the left. As you look down the picture, you can about halfway down or a third of the way down, you can see that we have more growth, and we can't necessarily between the beds where we have the treatments. And we saw this very specifically, especially in the cold areas and the cold, wet areas of the plants early. We had a better stand, and so these products work in causing the plants to grow better and be stronger. So it looked fantastic. And it was true on multiple varieties that we had out there. When we looked at yields, however, we saw that sometimes the untreateds out-yielded the treateds. And it was kind of interesting when we went back and looked at this, where we had the big decreases in yield. It was because we had lots and lots of foliage. And so the plants and varieties that were vigorous growers were even more vigorous with this particular product. In fact, there was so much out there we don't think the bees were able to even find some of the flowers. The varieties that were very slow growing and weren't as robust were the ones, in this case, like the cassava and the Santa Claus, that really benefited from this treatment. So as we can see, just because it works on one variety doesn't mean it's going to work the same on another variety. In California, we have a big crop called alfalfa. And the question is, does alfalfa respond to biostimulants? Last year, we did a trial looking at various biostimulants applied when we're very small plants to see if we can make them grow faster, to compete with the weeds. And as we can see here, there is basically no difference, maybe a slight increase in height. And then when we looked at the yields, for the most part, the biostimulants didn't give us any benefit. The only product in this case that did, the HM1666, to my knowledge, is a fertilizer-only product versus a biostimulant. So maybe we stimulated the wrong part of the plant to grow at the wrong time in its development. One of the other things we've looked at was a product called Toggle. And Toggle is an extract from seaweed, the Ascophyllum, and obviously it does lots of different things. It supports plant growth in times of stress. Supposedly it gives us yields, and there's lots of different things within it, being derived from a natural source. And it's kind of interesting, and as I'll draw your attention to the blue bars. Those were the ones where either we did not have a treatment applied of Toggle through the drip irrigation, and you can see on the far right where we didn't apply it, we had no results really. And our July 5th applications, where we applied about 23 days prior to cutting, again, we really had no response. But when we applied closer to harvest, at 18 days prior to harvest, in June and in August cuttings, we saw a nice, at least a tenth of a ton increase in those cuttings. And these are very large plots, replicated, and so we feel very, very interested that we're seeing some interesting responses from these things applied via drip, but we don't know that it would be as economical to do if we had to go over the top and do it foliarly. This may not work. We've also looked at things like dehydrator onions, because we grow a lot of those here in the desert where I'm located. And way back when, we looked at a GABA-aminobutyric acid product, and there we saw an application in April helped, another application in June, May helped. We put 2 applications. We got kind of a stepwise progression, and it looked really good. And that was a number of years ago. So we have some chance to look at some other products and a chance to really screen across all these different biostimulant classes to see what was happening. So the past couple of years, we've had some multiple trials. We've been comparing some foliar products. We looked at pre-germination and plus foliars, and some of the products we looked at are derived from our seaweed-derived products. Now, for those of you not real familiar with the Ascophyllum, there's lots and lots of hormones in us. Think about this. It's a plant. It's got all these hormones, and they do lots of different things. And we try to get these extracts from the seaweeds. You may get different extracts from different components of it. So every product's going to be slightly different into what they're going to be having out there. So we can't lump all the seaweed products together. Each one is different and hopefully unique. So the products we looked at in this particular study, one was called Cytopower. And again, you can see at the very bottom, there it's derived from Ascophyllum nodosum. It has some other hydrolyzed soy protein with it. We had the Cadian liquid seaweed concentrate in there. And we also looked at Guarantee Complex. These, again, are all things that have derived from the seaweeds. Now, if we look at our large plots that we did in our first study, we see the Cytopower gave us a pretty good increase where we put it on at 3 applications at 3rd, 5th, and 7th leaf. We got almost a 3-ton increase per acre in our numbers of dry onions, which is really, really good. Now, we also had a little bit less solids in there, so perhaps a lot of what we were seeing was water weight. But it was still very, very good, and it was very profitable to have a product like this applied. In 2020, or the 2019-2020 growing year, we didn't quite get the same treatments on at the same times. and we looked at a wider range of these products as well. So instead of getting 3 applications on because of COVID problems, we were only getting products on at 3rd leaf and 5th leaf for the most part. We also had some products that went on prior to the germination water the previous fall. One of the products we looked at, we mentioned before, was called VITAZYME, and there's multiple components to this product. It has a brassinyl steroid, it's got the 1-triaconitol, it's got some kynotin, gibberellic acid, indole acetic acid, biotin, and as you can see, some vitamins and some other things as well. Quite a few things in there. We also looked at transit foliar. I'm thinking it has some complex polymeric polyhydroxylic acids contained in it. We wanted to test it at 3rd leaf and again at 5th and 7th, but in this case, we only got it on at the 3rd leaf stage. Penergetic P is supposed to help some of our microbes, and we don't have a lot of experience with it. We do know in some of the European journals, it is referenced as a plant growth regulator. We also came back with a Penergetic product as well later on. We looked at a product called ADVANTIGRO. So it has 3 hormones. It's got some cytokinin, some indole butyric acid, some gibberellic acids, and 99% of it, 99.9% of it is other products. And we also looked at a product called Action, which is supposed to give us some stimulus of some of the plant growth. If we look at this, this is one of our products that we did. This is our pre-germination trial, and the purple bars are the guarantee complex. The green bars are the liquid seaweed concentrate. The blue bar is the Penergetic K plus the Penergetic P, and the white bar on the far right is untreated. Now, as we look at this, we saw some very interesting patterns happening. And if we go from left to right, we have the guarantee complex by itself, then put on it the next 2 bars are 1 quart, and the next 2 bars are 3 quarts. So as we look at this, it's kind of interesting where we put this product on at the 3rd leaf stage, we reduced the yields. And the more we put on, the more we reduced the yields. If we look at what we did at the 5th leaf stage, in those cases, we increased the yields from what they would be from the 3rd leaf in both situations, and obviously the higher the rate, the more the increase. So it gave us some clues as to what we might be seeing and what might be happening out there with this particular situation. It appears to us that this particular compound or a product being put on a 3rd leaf is not necessarily the best thing for onions, but the 5th leaf for this product looks like it's a very good thing, a very good timing in the development of the onion plant to make that application. The same is not quite as much true for the liquid seaweed concentrate. They're the combination of pre-germination water and that 5th leaf gave us some of our best responses. So we would really like to look at this again, and we will, because it's hard to say with just one treatment or one field site that we know of all the answers. It gives us some clues, but we need to verify this yet some more. If we look at our foliar products this year, we looked at the Action, the ADVANTIGRO, the Cytopower, gibberellic acid, the transit foliar, the VITAZYME, and at 3 different application rates there. And then we have the untreated. And you can see with almost no exception, when we started these products at the 3rd leaf stage, with the exception of the transit foliar, they gave us a numerical increase over the untreated. It's kind of interesting looking at the VITAZYME, which are the 3 bars there right next to the untreated on the far right, is that the 20-ounce rate gave us more yield than the 13-ounce rate, and then the 13-ounce rate followed by another 13-ounce rate at the 5th leaf gave us a yield decrease. So again, different compound than what we saw with the guarantee complex, and it seems like it's going kind of just the opposite direction. Again, kind of interesting things, and we're still learning quite a bit because there's so much to be learned. So I think there's a couple of things we can see at this point in time, is that we know at least the dehydrator onions generally, for the most part, have a positive growth response to the various biostimulants. But the application of the biostimulants relative to that crop development stage is very important. The growth development products or signals contained therein do not all have the same effect at all growth stages. And we see these dehydrated onions, at least, are responding differently to different products at different growth stages. And I think we'll see that probably be true for every crop we grow out there. When we're trying to build something, we need to have the right materials in the right amounts at the right times. So why is our success not being consistent? Well, we've seen some things here in the past that kind of tell us that maybe sometimes we're not getting the product into the plant. Even though we're spraying it on, it may not be getting into the plant. It could be a surfactant problem. It could be the wrong surfactant, or maybe not the right time. It could be a lack of nutrients out there that are being available for what we need. And it could be, well, combinations of the above. So it makes you kind of wonder, in the past, how many of our past biostimulant study results have ended in no positive growth responses or results noted because we had something else that got in the way. So there's much to be learned yet. So let's talk a little bit about the future. If we look about the future, well, good question. What does the future hold? We're going to take some guesses, and we're also going to see what we're doing here very quickly here in the next few years. So as we know, there's so many crops and so many growth stages, and there are so many biostimulant products, but there's nowhere near enough people or time to extensively test and comparatively test all these products to see what's happening. So there's a huge amount of information that needs to be developed and so much to be learned. We know that there's new products coming on the market almost every day. And just because something doesn't work the first time doesn't mean it won't work the next time. Sometimes it is the case, though, it does not work. We know that one of our organizers for this series, Rachel, is going to be doing some work on garbanzo beans, I think this winter, with gibberellic acid. We're going to continue looking at various products and comparing them, and dehydrated onions. There's other products we'll be looking at, and other people will be looking at on crops like garlic, and there's probably going to be lots of other trials as well. But I think it would be kind of interesting to see how these things work. It's difficult enough to get one product to work, and yet comparing them all in the same field trial is rather challenging. So at this point in time, I think I've reached the point where I'm supposed to open this up for questions. So Dr. Wang, I'm going to turn it back to you, and we'll go with the questions if there are some questions at this point in time.
Thank you so much, Michael, for your excellent presentation. There are lots of great information. Let me do this. We do have a couple questions in the Q&A box. I will read them for you. Okay, the first one, when do you anticipate that quality improvements and or nutritional improvements versus yield alone will also become part of the benefit measurement to show product efficacy?
I think the answer on that one is going to be crop dependent and what the final use of the crop is going to be. I think we're seeing some people looking at those things already to increase some of the quality components. It's going to be crop by crop specific. And so for some crops, it may not ever be a big thing. But there are some where you're looking at specific components that are going to be highly valuable that they will do that. And it's also part of the cost of efficacy as well.
Okay, thank you, Michael. The second question is, could you describe the extraction methods to the beneficial components out of ascophyllum? Some processes are very ascotic and can break down components. Is that correct?
Each company has different ways that they're using to extract the different components from the seaweeds. Some are doing some cold presses, others have some other presses, and some have chemical extractions. After those points, some of them are obviously running through different filtration aspects or molecular weights to get the compounds that they want or the specific molecules that they want. And I think if I was trying to answer for every company, I would probably get every company mad at me. But let's just say that every company has their own way of doing it, and it's for what they're needing, for what their needs are. Because some may be looking to extract the oligosaccharides, some may be looking for something else. And so I think it comes down to company by company how they're doing it and what they're needing. And that I think probably the best people that can answer this question are the ones that are actually doing it, because they can probably answer more specifics on this than I can, just because they have the experiences to do so.
Thank you so much. We have another question here. Are there any trial results for nut crops such as pistachio and almonds?
There probably are, but I didn't have access to them through the UCCE people, if they exist. I'm sure there's other trials that have been done by lots of people outside the University of California, but we were just trying to keep it on focused on things the University of California and their people have done. So I'm sure they've been out there. I know they're out there, but I don't have those available.
Okay, thank you. Well, probably have another couple questions here. For the plant growth regulators or hormone that you use here in the study, what's the difference between them with the biostimulant? Do they must attach a root to perform their job, such as, for example, for those biostimulants using the microbes as their active ingredients?
Okay, could you repeat the question, please? I didn't quite catch it all.
Yeah, so for the hormones you used or regulators that you used during the trial, when you apply them, do they must attach roots to perform their efficacy?
It depends upon where their application is. If they're applied to the foliage, they're not necessarily attached to the roots. If they're in the soil, obviously they're going to be signaling the hormones in the roots. And sometimes you're going to see different levels and concentrations of what's in the foliage versus what's in the roots on some of the hormones.
Thank you. Another question here, why there are proper timing exist? Do biostimulants have just a transit effect? So
the question is, why do we see differences at different stages of growth? Well, I think we all know as plants grow, as humans grow and everything else, the hormone levels change over time. And obviously we're signaling different hormones or different levels of hormones, and there's also feedbacks. So the products that are triggering and focusing on signaling certain hormones are going to be more effective at certain times. But obviously we know from our studies that we do not necessarily have a great handle on these. We're still learning. We're really kind of in the infancy of understanding how these all work in a field situation, especially when we're comparing things. So it's a great question. I wish I had a better answer, but we do know that things are not static. Things are constantly changing with hormone levels in a plant, and different ones are coming on and different ones are shutting off genetically. So, or levels of it, and that's what's happening here is the interactions with these products signaling the different hormones within the plant.
Thank you, Michael. Another question, in the melon trial that you mentioned, you have a larger canopy, but without a increased yield. Did you see delayed maturity of the fruit? Or is that very common for other crops that use the biostimulants?
In this case, I don't know that we delayed anything as far as maturity goes. Where we had the reduction on the melons is we believe it was not a reduction in yield due to maturity. It was a reduction due to bees not being able to get through all the foliage to get to a lot of the flowers. It was very interesting to see how large that foliage mass was. It was 2 to 3 feet up. It was very, very large, and there are a lot of flowers in there that the bees are not necessarily going to go to if they got something else close by that's easily accessed. And I think that was probably the big thing that with that particular trial. It was not a maturity thing. It was just a pollination hindrance with a larger growth.
Thank you, Michael. Then there's another question. For the area like where you are, if you use the foliar application of those biostimulants, will they just evaporize? Or what's the best way to do that?
Around here, a lot of the biostimulants we will use a surfactant with them. A lot of times we'll have a bit of an oil base with them to keep them wetter longer in our arid environment to help them get into the plant. We usually check with each of the manufacturers for what they recommend, and some will have very good definitive ways and surfactants to use, and others have not looked at that. We also know that surfactants efficacy can change also from crop to crop because of the differences in the waxy cuticles on the plant as well. So it's kind of like almost going back to pesticides in a way and trying to figure out how pesticides work. Mm-hmm. And because we've seen a lot of the same sort of things with pesticides, the right surfactant on the right crop to make those things work. The similarities also exist with plant growth regulators. They just have not been studied nearly as extensively to make the same things happen.
Thank you, Michael. I think that's all the questions you have, and thank you very much again for this informative presentation. And thank you everyone for your participation, and I hope you enjoy the rest of your day. Thank you so much.